So the relation between the electrical susceptibility and dielectric constant of the medium K. So this dielectric constant is also called as relative permittivity, and it is also called as specific inductive capacitance, SIC. And we want to find the relation between electrical susceptibility and dielectric constant of the medium. And the relation between these two is K is equal to 1 plus Chi into E. Or from this equation, the Chi electrical susceptibility is equal to K minus 1, or which is equal to epsilon R minus 1. So relation between dielectric constant of the medium and electric susceptibility is K is equal to 1 plus Chi E, or Chi is equal to K minus 1, or which is equal to epsilon R minus 1. Then to prove this relation, so proof of this relation, K is equal to 1 plus Chi into E. We know that electric field without dielectric, that means with air, which is equal to E0, and electric field due to induced charges, which is equal to EP, and net electric field is equal to E0 minus EP. So this is equation number 1. Again, the value of EP, electric intensity due to polarized charges, is given by equation charge density due to polarized charges divided by epsilon 0, sigma P divided by epsilon 0. Say this is equation number 2. Then equation number 1 becomes, substitute this value in equation number 1, we get E is equal to E0 minus EP is sigma P divided by epsilon 0. This is equation number 3. Again, this equation number 3 can be written as E is equal to E0 minus P divided by epsilon 0, because since sigma P is also called as electric polarization P. This is electric polarization. So this is equation number 4. Again, electric polarization P is given by formula P is equal to epsilon 0 chi E into capital E. This is equation 5. So substituting equation 5 in equation 4, we get here E is equal to E0 minus this value of P, and the value of P is epsilon 0 chi E into E, and divided by this epsilon 0. So this epsilon 0 gets cancels, and the remaining terms are E is equal to E0 minus chi E into E. And we write again E plus chi E into E is equal to E0. And from this, if we take common E, then we get E into bracket 1 plus chi E, which is equal to E0. Suppose this is equation number 6. And from this equation 6, we write from equation number 6, we write 1 plus chi E is equal to E0 upon E. And this 1 plus chi E is equal to K, or which is epsilon 0. So here 1 plus chi E is equal to E0 upon E, where E is the electric field between two plates when the dielectric is introduced, and hence our first relation comes out, which is K is equal to 1 plus chi E, and from this relation we write chi E is equal to K minus 1, or which is equal to epsilon r minus 1. So this is second expression. So the proof of K is equal to 1 plus chi E, or we have discussed the article relation between the electric susceptibility and dielectric constant of the medium, or relative permittivity of the medium, or specific inductive capacitance lecture. So in today's lecture, we have studied the meaning of dielectric, then types of dielectric, which is polar dielectrics and non-polar dielectrics. Then we have studied electric polarization, and from electric polarization we have studied the electrical susceptibility, and finally we have found the relation between electrical susceptibility and dielectric constant. And also we have studied the electric polarization. Now the example is a rectangular slab of non-polar atom is placed in electric field. All atoms will be polarized, gets polarized. induced charge, since the induced charge is -5 microcoulomb and +5 microcoulomb, are developed on two phases of dielectric. Area of each plate is 0.08 meters square. Then calculate polarization density. Number 1, polarization density. Number 2, calculate electric susceptibility. And number 3, dielectric constant of medium. So this numerical is based on today's article. Here, rectangular slab of non-polar atoms is placed in electric field, then all atoms will get polarized. Since induced charge is 5 microcoulomb and -5 microcoulomb are developed on two faces of dielectric, and area of the two plates between which dielectric is placed is 0.08 meters square. We have to find polarization density. We have to find electrical susceptibility. We have to find again dielectric constant. So, first of all, we will calculate polarization density. As we have provided Qi, induced charge, which is equal to 5 microcoulomb, which is equal to 5 into 10 to the power -6 coulomb. And area is provided 0.08 meters square, that means 8 into 10 to the power -2 meters square. And electric field is also provided. So to find electric susceptibility, electric field is provided, and the value of this electric field is 1.5 into 10 to the power 4 Newton per Coulomb. So E is also provided. E equal to 1.5 into 10 to the power 4 Newton per Coulomb. So to calculate first, the polarization density. So to calculate this polarization density, the formula is polarization density P, electric polarization is equal to sigma P, and which is equal to induced charge or polarized charge divided by area. And if we substitute the values, the charge is 5 into 10 to the power minus 6 and the area is 8 into 10 to the power minus 2. Then polarization density is come out to be 5 by 8 into 10 to the power minus 4, which is equal to 50 divided by 8 into 10 to the power minus 5 and is equal to 6.25 into 10 to the power minus 5, and the SI unit of polarization density is Coulomb per meter square. So this is the first solution for polarization density. Now secondly, we have to find the value of electrical susceptibility, and we know the formula. P is equal to electric polarization is equal to epsilon 0 into chi e into P, and therefore electrical susceptibility chi e is equal to P divided by epsilon 0 into E. So which is equal to, as we have calculated the value of P, which is 6.25 into 10 to the power minus 5 divided by epsilon 0 is 8.85 into 10 to the power minus 12 into E. E is given, which is 1.5 into 10 to the power 4, and if we calculate this value, then it come out to be 470.3, because chi e is a unitless and dimensionless quantity. It is a pure number. The value of chi e comes out to be 470.8. And finally, we have to calculate last term in this problem, which is calculate dielectric constant of the medium. And in order to calculate dielectric constant of the medium, that is K, we know the relation between electrical susceptibility and dielectric constant of the medium. So dielectric constant of the medium K, or relative permittivity, is given by formula 1 plus chi e, that means electrical susceptibility. So the value of this K, dielectric constant of the medium, come out to be the value of chi e we have calculated, which is 470.8 plus 1, and which is equal to 471.8. Again, it has no dimensions, no unit, because dielectric constant or relative permittivity is the ratio of two quantities, permittivity of medium divided by permittivity of free space, epsilon upon epsilon 0. After discussing articles dielectric, polar dielectric, non-polar dielectric, electric polarization, then reduced electric field when the dielectric is introduced between the electric field, then definition of electric polarization, formula for electric polarization, electrical susceptibility, and finally we have discussed the relation between electric susceptibility and dielectric constant of the medium. And on all these articles we have taken one numerical finally. So in next lecture we will going to study the concept of capacitor.